Uh, Topic here I'm going to cover is talking about enterprise Hadoop. Before we get into Hadoop, enterprise Hadoop, I just want to cover a high-level overview of what Hadoop means. I know it's going to be a repetition to some of the folks. I apologize, but just to make sure everybody else is on the same page, I'll quickly go through the Hadoop ecosystem, what it means to us, high level. So we know Hadoop comes from internet companies, started at Google, and Yahoo did a lot of work and made it more open source. And now we are at a point where the enterprise companies are looking at Hadoop and trying to figure it out how they can leverage this technology to make their jobs run faster, make their applications run faster, or maybe some cheaper storage. So many ways where enterprises are looking at Hadoop, and of late, since last year, we have started to feel that there are some enterprises who are adopting into Hadoop. They have their own challenges, but they are looking at it in a very serious way. About me, I'm here at NetApp for last 8 years. My 3 years at NetApp have been very interesting. I've been doing all this Hadoop stuff. 3 years back, I didn't know anything about Hadoop, and now I know a little bit of it. It's a very wild, wild west land. You can do everything and you can stand nowhere. That's the thing. There are so many options to get things done, and there is no one way to get it right or to do the things right and get it rolling. So we are going to discuss some of them, what it means to us, what it means to enterprises, challenges, and everything else. Coming back to Hadoop, Hadoop consists of two main pieces, HDFS and MapReduce. HDFS, as we know, and I think my friend from Works in the previous session, Suresh Srinivas, he covered HDFS very well, and he's kind of one of the gurus of HDFS. But HDFS is Hadoop Distributed File System, which is the core file system to store data into our platform. And the MapReduce is the framework, the software framework, which enables running apps and analytics jobs on top of that file system. So this is all about Hadoop, HDFS and MapReduce. Hadoop is now mainly an Apache Foundation project. This means everything is free. And the key players are these startups, which are big names now. Cloudera, Hortonworks, Mappa are the key startups who have done a lot of work in building Hadoop for the enterprise, a supported Hadoop ecosystem. And then IBM, Pivotal, they have been there for a while, and they are also adopting into the Hadoop ecosystem. Hadoop in enterprise is going to see an explosive growth in next couple of years as far as IDC and other reports, their projections. Almost every enterprise, of course I come from NetApp, so our customer base is all about enterprise. So almost all of our customers are looking at it, trying to figure it out, what they have to do with this, and where this technology will fit into their traditional data centers and application era. So they are trying it out. So we are going to talk about that growth in the next slides, but before that, let's talk a little bit about the traditional Hadoop architecture. What it looks right now, as our friend from Hortonworks and everybody else says. So if you want to build a Hadoop cluster to do something, you just gather up a bunch of servers, white boxes, just general white boxes, cheap, inexpensive hardware. You just gather it up, you carve out a main machine, which is known as the master node. Master node is the metadata server, and it's also called as name node. So you build the first machine, which is called the name node, who is going to have all the metadata, all the file system information, everything about the cluster. So that's called name node. You need another little piece of box, which is called secondary name node. It's not the high availability name node, but it does offload some of the management tasks from the master node. It's a helper guy from master node to make sure that the master node load is balanced and it does a lot of management tasks for metadata for the master node. So that's the second node. Now you run a lot of jobs on the Hadoop cluster. So who is going to manage all those jobs? Hadoop is all about batch processing. So you need a daemon, a process, which is going to manage those batch processing. And that's called a job tracker. The job tracker is another server. People like to have another dedicated server, which is thrown in just to manage those jobs, and that's the job tracker node. So great. These three basic pieces are essential for any Hadoop cluster, and you have built them. Now you need the worker bees. These are all worker bees. So you need storage and compute. So Hadoop basically works on the fact that storage and compute, they are all together. So storage, they are built on the analogy that storage and compute, they work together so that there is minimum latency between the two and you get the best output, best performance. So you introduce these boxes which are known as data nodes, and they need to serve a lot of storage. A lot of storage means you add a lot of disk drives. The traditional pizza boxes, white boxes, they have something like 12 drive slots. So you put 12 or 14 drives on those boxes, make them a big fat 2U servers. They have, I do call them fat servers, so they are big, fat, heavy machines. They are called data nodes. A lot of compute, typically 8 or 16 cores, 100 gig, 100 or 128 gig of RAM, maybe 192 gig of RAM, and 12 drives. 12 3 terabyte drives. 3 terabyte is the mainstream drives you get. So that makes a data node. Data node is the guy who is going to serve all the data, all the storage, as well as all the compute. Then you add more data nodes based on your use case, and you need racks and racks of data nodes. And now Hadoop is built. Now you need to protect that data, and you want to make sure that all the data is resilient. So you start copying that data. Hadoop itself has an inbuilt copying mechanism. They call it replica. So every piece of data is replicated 2 or 3 times. Minimum is 3. So you add racks of servers. So for every petabyte of data you want to build on Hadoop, you actually buy 3 petabyte worth of storage, 3 petabyte worth of CPUs or servers to hold that storage. So that's the way you have built the traditional Hadoop. Perfect. All works great. Everything is connected through network, and you have all those features coming from SDFS. Everything for free. Great. Now here it comes. What are the issues when it comes to an enterprise data center? Traditionally, Hadoop was evolved in all those internet companies. Petabytes and petabytes of data. 3,000, 4,000, 50,000 servers cores. That's what they claim about. And great, it all works. They can have racks and racks of servers. They have multiple clusters. One cluster doesn't work, some failure happens, they have another cluster which will take over. And that's what it builds, like 44,000 node clusters, which Yahoo claims, so 1,000 nodes. I mean, they don't even talk less than 1,000 nodes. It's all about thousands and thousands. No. For an enterprise, I don't think they will need 1,000 nodes. I haven't seen any enterprise hitting more than 300 nodes. Most of the workload is done within enterprise within 100 nodes. Great. For an enterprise with 100 nodes, they have to have 3 more copies. So they will have 300 nodes just to maintain that data and replicas. So 3 server replication 3 for an enterprise becomes a pain because they got to manage everything. Server boxes are cheap. These boxes are very cheap. But in an enterprise with a lot of processes and a lot of functions, building these racks of servers, provisioning space, power, system administration, network, everything becomes a very expensive proposition. And that's what they have to do. Management becomes a big expense for an enterprise guy. In the Hortonworks presentation, we learned that it's very easy to manage. For a 3,000 node cluster, you need just 1 system admin. Great. But for 40 node cluster also, you need that 1 system admin. That's not great. So that's where comes the enterprise pain point. Another big pain point is network congestion. This data resiliency in Hadoop is based on replicas of data. A disk fails or a server fails, no problem. We have two more replicas of the same data set somewhere else in the cluster. We are not going to lose any piece of data. Great. But here's the thing. When the disk fails, it's a 3 terabyte drive. 3 terabyte drive worth of data needs to be re-replicated in the whole cluster. So for a 1000 node cluster or even a 100 node cluster, 99 nodes are going to work to replicate those 3 terabyte of data. No issues. But what if there is a 40 node cluster? That 3 terabyte data needs to be replicated by 40 nodes, which is going to put pretty considerable pressure and resources on those 38 or 39 nodes. Facebook has admitted that network congestion is a major problem for them, and that is because of maintaining all those replicas. So the same network is being utilized to re-replicate the data in terms of failure, and the same network is being used to manage the whole cluster, run the jobs, run the map and reduce component. So at some point of time, map reduce jobs will show some latency. You may not expect the output in the same amount of time as you expect when the failure doesn't happen. For an internet company, it doesn't matter if your Facebook post appears in 5 seconds or 5 minutes. But for a software, for an analytics company or for a bank like Wells Fargo, if your statement doesn't show up in 5 minutes, you get frustrated and you start complaining the bank. That's not permitted in enterprise. Enterprise is all about service level agreements, SLAs. And that's where we are talking about building an enterprise quality, enterprise grade, SLA-driven cluster. So let's see, how do we address all these issues? So I already covered these issues. So flexibility of scaling. Now let me put some note on this scaling issue. It's not a big issue, but for a small cluster on enterprise level, it could be an issue. What happens if you have a small cluster and you realize after a year or so that I want to add a lot of storage? My jobs, which were using the data, it's like a petabyte of data, and I thought that I'm going to keep this data only for 3 months and then throw it away. But you realize that I'm getting hell lot of precious information out of this data. I want to keep it for another year so that I can run my yearly reports on it as well. Great. You can do it, it's all cheap hardware, but you're not going to use it every day. So it's like cold data now for another 9 months. So it's like an archive, deep archive storage. You're not going to use a lot of CPU to manage that data, but you need some big fat storage to keep it for another year. So you got to find out. In a traditional Hadoop way, if you want to scale that system, you need to add storage. If you want to add storage, you have to add more servers, because servers and storage are all tied together. Now we are going to find a solution out of it, but let's hold on to this thought. Flexibility of changing architecture is another big pain which I have learned from my customers. Everybody is an early starter in this field. So they start with something out of the box, they try to build a cluster, they run their use cases, and then they realize that, okay, I think I'm done with my Apache project, I may run map on it. Or maybe I would go for IBM Big Insight, Sphere distribution, or something like Cloudera, something like Hortonworks. If you build a Jain solution, then you're stuck with that particular architecture. You cannot scale. So the architecture has to be very, very open. So we got to stick to the open architecture and still offer all the independent scaling of compute or storage and all the resources. There is one more, I already covered the copies of data, multiple copies of data. Network congestion we covered, fragmentation and storage efficiency. So what is fragmentation in the cluster? What happens is, let's say a disk drive fails on a data node. No worries. You replace if that disk died with a new drive, that 3 terabyte drive is sitting empty on that cluster for a while till it gets populated. In a traditional Hadoop, the way the whole sizing works is that you assign certain number of cores, CPU cores on a data node to a certain amount of disks. So if the disk doesn't have that data, the cores which were assigned to that disk is sitting idle. So now there is a huge imbalance between the efficiency of the cluster. Some CPUs are saturated, they are working 24/7, some cores are just sitting idle. In order to mitigate that issue, there is a feature in HDFS which is called cluster rebalance. You have to run that rebalance process. That process itself takes a lot of CPU and resources, memory resources on all the data nodes. You have to rewrite, you have to resilver all the disks. So that, sometimes what happens is like some enterprise customers I've seen, they have like every quarter they will have some kind of downtime on the cluster and they run the rebalance. So this means there is downtime. And they cannot afford a downtime, so what they do is they end up having another cluster where they will continue to run jobs and they will have this cluster doing the rebalance job. So additional investment in having more clusters. Question?
You said during that rebalance, the disks are resilvered, meaning all the data is lost?
All the data is not lost, but it's rebalance means some disks are like 80% full, some disks are 30% full. So they are going to rebalance the data. All the blocks are written.
Okay, they
redistribute. Absolutely. Okay. Yeah. Any other questions? I can take a pause.
Well, I do on network congestion. Is this the right time to ask questions?
Sure.
Okay.
Yeah.
So we know that there are new network technologies being invented. For an enterprise Hadoop cluster, or for the data center, you decide. Which is the optimum network technology and topology to use?
So, great question. So for an enterprise, we always suggest going with a 10-gig network topology, top of the rack. That's what we suggest. You can go with 1 gig bonded NIC pair depending on the scalability of the cluster, but normally 10 gig is becoming mainstream nowadays. Nowadays it's inexpensive and you can go for it.
How about cloud? Using cloud, base.
You can always use cloud, absolutely.
Yep. So it's the same for network, bandwidth.
All those things, all those issues are eminent in cloud also, but the cloud service providers, they take care of it.
But how about the enterprise connection to the cloud? They have a internet, connection,
Yes,
bandwidth.
those are the cloud issues. I think we can talk those cloud issues maybe after, once I finish this.
Okay.
Like that.
All right.
Those are, of course, data, uploading data to cloud and bringing in and out, bringing data in and out of cloud is always an issue, but it depends on the amount of data and SLAs guided by the customer.
Okay, I'll talk to you later. Yeah.
So another one is manageability. We already talked about manageability in terms of skilled resources. Of course, managing a Hadoop cluster is a job of a skilled person. Not everybody knows this technology. And we already have learned that there is a lot of scarcity of skilled resources to manage this. Now, 3,000 node cluster or 30 node cluster, you need a system admin. That's an expense. Enterprise IT may not be able to afford this kind of manpower, which is very expensive to manage a small cluster, and they may want to offshore it, or they want to share it with somebody else. So let's find a solution what an enterprise cluster can look, and how can we offload most of the management tasks out of it. So all in all, what I want to emphasize here is that managing 1,000 commodity server doesn't equal to managing 1,000 node cluster of commodity servers. It's a complete different thing. 1,000 commodity servers can be managed. You can throw out things. You can schedule downtimes. You can do various things. But when it comes to a big cluster of 1,000 nodes, there are a lot of management tasks associated with it. There is a lot of risk. permissions and boundations, which can make it a big hassle. I think rest of the stuff we already covered. Science project, doing science project on white boxes is very easy, but when it comes to enterprise IT shop and enterprise SLA-driven data center, then you got to look at a completely different approach to build and design such systems, and we're going to talk about it. So let's talk about what we did at NetApp to address some of these issues. So NetApp, we know, is a storage company. For us, storage is the center of the universe. So everything we starts from storage. So here's the cluster which we have built using commodity servers. Great, everything was great. Now, in order to make it more enterprise friendly and address some of the storage issues, what we do here is we bring in a couple of storage arrays. Now, every data nodes we talk about has 12 drives, 3 terabyte drives, which is offering all the storage capacity for the cluster. What we do is we take the drives out of those data nodes and move the data to the storage array. Now, once you take out the 12 drives out of the data node is either diskless or maybe just one disk with the operating system. So that becomes a very thin data node, just like a 1U pizza box, or maybe 1U with 2 servers into it. That's what nowadays you are getting with Dell or Supermicro. So very thin, slim, tight pizza box you're going to get. You do the same for everything, and this is what you build. What you have ended up doing is you have a set of data nodes, slim, thin data nodes. Instead of the thick fat servers, you have thin data nodes, 1U boxes, and you have bunch of storage arrays which are serving all the data. You connect them through a direct attached SAS link, or you can do InfiniBand, you can do fiber channel or iSCSI, anything. But we decided to use SAS, direct attached SAS link, just to comply with shared nothing architecture of traditional Hadoop. So this is what we ended up. We have an array of compute servers and then a whole set of storage devices. So I call them personally a compute bus and storage bus. So now you have a really decoupled compute and storage from the whole cluster. Storage, which has all the data, sits on enterprise class storage arrays, and data nodes become real commodity. Real commodity means you don't have anything significant sitting on those data nodes now. All the data is outside of those boxes. If something fails on the data node, just throw it away, replace with a new one, mount the same storage, you're back in business. No need to migrate data, no need to think even of replicating that data. In the traditional Hadoop, we are talking about triple level replication. In this model, you may not even need replication unless you have a requirement of job parallelism, or you are concerned about rack awareness, or you're concerned about switch failures. You talk about some replication, maybe replication of 2. Otherwise, you don't need.
Is that because in your storage array you already have the redundancy built in?
Absolutely.
Okay.
So it's a storage enterprise class storage array. What you get from EMC, NetApp, or anybody else, our customers are already comfortable putting their enterprise data on those storage arrays. They have a proven reliability. They're all protected by RAID. So if there is a disk failure or something failure, it's all taken care at the storage array level. These data nodes will not even know if a disk has failed. Everything is taken care. So now you don't even talk about the network saturation. You don't even talk about the disk failure and replication. You don't even talk about all those issues Suresh was talking about, that in large clusters there will be some issue at card level or network level or server level, and you have to kick off replication to mitigate those issues. All those issues are all gone just by this storage array.
Is the SAS become a bottleneck then?
SAS at this point, I don't think it's going to be a bottleneck. Single SAS card offers a bandwidth of 6 megabytes per second per channel, and we have 4 channels, so 24 megabytes per second. I think spinning disk will become a bottleneck before the SAS card becomes. So these storage arrays which we have selected are like a very dense LSI logic storage arrays which NetApp bought a couple of years back, and these just store blocks. You get something like 60 drives in a 4U chassis with 2 controllers, redundant controllers, and then multi-protocol in terms of fiber channel, iSCSI, InBand, or SAS. We selected SAS because it's cheap, inexpensive, and high bandwidth. But you can do anything. In fact, a lot of customers, enterprise guys, they have strict mandates that they want everything fiber channel. They have a storage group, they have a server group, and both have their different standards, different SLAs, different ways to configure system. They don't care about the cost. I want everything on fiber channel. All right, you have it. I want everything as standard server rack of 1U, no drives. Some customers, they talk about everything is LAN boot, everything should be iSCSI boot. There are some customers who have strict mandate that all our compute must be virtualized sitting on VMware virtual machines by 2015, no matter what happens. Storage has to sit in a storage silo, compute has to sit in a compute silo. This is all enterprise requirement. They are not dictated by internet-based, these thousands and thousands node clusters. They are very different, and that's what we are trying to solve. I can take more questions here.
Then why have so many data nodes when I can have a few blade servers, each one full of multi-core CPUs?
Yeah. No, I'm sorry, I'm not.
Following forward from the logic of what you've been saying, why have separate data node white boxes? Instead, why not have one blade server, each blade with multiple microprocessors, each microprocessor with multiple cores, and you only need a few blades then to reproduce everything you've pictured on the left?
Great question. Absolutely. You can do that, and I'll cover that.
Okay.
Just hold on 10 minutes.
Right.
I will cover that. Absolutely. Any more questions here? So, the architecture which we talk here right now gives us a lot of flexibility. By decoupling storage and servers, you can independently scale. Your job needs more CPUs, but you're fine with 200 terabytes of data. You don't need to buy a lot of this. You just keep adding more servers to the same storage. Here, if you need deep archive, you don't care about compute. You're happy with the compute. You want to add more disk, just stack in more expansion units to those storage arrays, and don't worry. You don't have to change any configuration on the servers. Nothing. Everything is online. Everything is even managed online. If there is a disk failure on the server, the storage array management utility will send an email to somebody or maybe to the vendor, and they will take care of the disk replacement. Everything is online. No impact of any storage related issues on the servers. In the same way, no impact of any server related storage issues on the storage. Very independent and still working together to get the job done.
Question?
Yeah.
Is the job tracker a single point failure?
Job tracker?
Yeah.
Job tracker is a single point of failure. I think Hadoop 2.0 has come up with the job tracker high availability. But another way to look at it, job tracker is a batch processing manager. If the job tracker fails, you're not going to lose anything except the jobs. And that's true. I mean, in an SLA-driven environment, you need high availability for job tracker. And that's why Hortonworks and Cloudera, they're talking about now enterprise features. So they admitted that Hadoop was not enterprise ready. Now they are trying to build all those capabilities into HDFS. So they are trying to build that high availability job tracker, high availability name node, and everything else. And this is where we are trying to solve the infrastructure problem to make it more enterprise friendly. Yeah.
Quick question. The first time I heard about solution, yeah. So here you say that server replication equal 2, right? So
Yes.
in the data node there, they have a disk there already. They have disk.
So server replication 2
Yeah.
is based on HDFS and data node replication.
Yeah, but they have a storage disk there, right? In the data node
No, the storage is still
or in the
here.
share.
It's not shared, but it comes from the storage area.
Oh, I see.
Yeah.
Okay. All right.
And you don't really need.
So
server-
yeah, so I can look at that. They have a data node without the storage disk. It's,
Yes, you can have
Alright,
diskless
okay, alright.
data nodes.
Okay.
Absolutely.
Uh.
I think I covered most of it. Flexibility of changes, I already covered. Optimized infrastructure investment. That is something which I learned from one of our customers. I mean, after they bought the whole solution from us, we asked them what made you think investing in this infrastructure at a very early stage. And he said, we are new to Hadoop. We were not sure whether Hadoop is going to solve our problem. So what happens if we decide that Hadoop is not the way we want to go? What do I do with my investment? So going with the enterprise class infrastructure guaranteed their investment because they can reuse all that infrastructure for other applications like Oracle or VMware or something else. So their investment was protected very well. And hardware is very cheap, but building the infrastructure based on that hardware in an enterprise data center is a very expensive process. In fact, we always talk about hardware's cost, but when it comes to deployment, the biggest problem I have seen is getting data center space at the customer side. Very tough to provision. It's like a 6-month lead time just to get data center space provision, network provision. Very expensive process. So those processes nobody even talks about those things. There is a cost associated with those processes and investments. And we always talk about hardware. Is this HP server is cheap or Dell is expensive or IBM or NetApp cheap or expensive? That's nothing compared to all those OpEx costs. So we covered most of the key advantage over here. Independent scaling of computing storage is covered, less replicas, rate-based protection. Yeah, guaranteed performance. That's a great point. I want to talk about it. I know I'm going to get you bored about the disk failures, but here is one situation. A disk fails on the cluster, and there are jobs running on that server which were associated with the data sitting on that disk. The jobs were 3/4 done, like let's say a 5-minute job, 3/4 of it is done, and the disk fails. No problem, Hadoop will refire those jobs to a replica copy of that data somewhere else in the cluster. Great, but you have already lost those 3/4 of the job time, only 3-minute worth of job. So your SLA is already beaten up there. Now the job will restart and it will refetch all the data and get you the results, but you have lost the window. That is not acceptable in an enterprise environment. You need to have a predictable approach to such failures. If you have a rate-based storage over here, disk fails, you know how much performance impact will that disk fail cost. In our testing, we have found it's just 10%. So in your SLA, it's already written that the job run window is from this much time to this much time, which includes any failures associated with the disk. So that's a predictable job, predictable SLAs. It's very important for enterprise. Management is something which we already covered. When these enterprise arrays come from vendors who have a guaranteed SLA and turnaround time, then it makes it much easier for enterprises and they feel very comfortable, very safe and secure. The data is already stored. So another one thing I want to touch upon is financial customers. They have very strict mandate that they are going to store their data only on storage arrays with disk encryption. Now disk encryption on open servers could be very tough. but these enterprise class arrays do offer those kind of capabilities. A lot of security, a lot of encryption, a lot of manageability. This answers your question, Roger.
Mhm.
You were asking about, or not, I think you asked about how come we use those arrays of servers, or instead of using rack mount servers, we can use this
Great.
tray-based server, I forgot the name. So we have partnered with Cisco and IBM and everybody else to build this pre-canned, pre-tested, validated, SLA-driven Hadoop architectures. We deliver them as is. They are all very well documented in terms of performance, in terms of management, everything. So for customers, they don't have to think that I buy servers from here, I buy storage from here, I buy network and everything else, who is going to manage. It's all pre-built, it's all pre-canned, well-tested, validated. All you have to do is click, 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 order, and it will land up, roll it out of your cart, and you're ready to go. This is a little marketing hack I'm getting up from the lab. With this, I'm done. Thank you.
So what is the network interconnect in that rack? Is it 10 gigabit Ethernet?
It's 10 gig Ethernet. It's a Cisco Fabric Interconnect, Fabric Manager.
So why not fiber optic?
That comes from Cisco, maybe. It's a Cisco question.
I was hoping for more general acceleration. Okay, fine. Thank you.